Hey, this is Eugene, and today we're going to talk about Berry Farm contract, which is supplement of the Berry Club that allows you to convert your bananas to cucumbers and farm near. So let's first do quick review. What is a berry farm? And let me present. Okay. Okay, so Berry Farm is a very well-designed app with large text and a lot of emojis. So the way it works, it displays your balances once you're logged in. It pulls it from two different contracts as well as your account. So it combines them from multiple sources. Avocado and bananas, they come from Berry Farm or Berry Club contract, and cucumbers are local for that contract, and near comes from your account balance. So if you farmed anything, then you get rewards when rewards are distributed. So it seems like someone did a lot of avocado purchases recently, and rewards actually increased. So it also has a global stats, which means 2.5K near was transferred from Berry Club to Berry Farm, and also I earned 100 near, and my reward gonna be this based on amount of cucumbers I have comparing to the total number of cucumbers. So total number of cucumbers is 54K. I get 3% share of this reward every time there's a reward. So when I click refresh, basically refreshes stats from multiple accounts, and I can claim near, which is transfers them from the contract to my account. And I can also swap bananas to cucumbers. And what happens is I'm doing a call to Berry Club contract saying I'm going to transfer this vault, which is using the new standard. And it requires a small amount of near. I think it's like 1 yocta near to confirm that I'm not doing this through access key. So I cannot do a transfer through an access key to avoid automatic like withdrawing, and this is just a safety guard. So if you, for example, would authorize a Berry Club from some other app that tries to like drain all your bananas, it would fail because it will not be able to call transfer row or transfer this vault. Transfer row is the new name for transferring without a contract, so you can just deposit on someone account that exists. And transfer row or in transfer with wallet is calling the receiver to withdraw tokens. So I spend 10 bananas, get more cucumbers, and I can like refresh a balance again to see if someone draws something. No. So that's how the UI works. But there's more functionality to this than just this UI. It actually, the contract supports cucumbers as a fungible token, same as bananas. So you can potentially build another app that transfers cucumbers. And there's one more, which is banana swap that Vlad Gorchina built. which is kind of like a simplified Uniswap with single pool where you can buy and sell bananas. So for example, I actually haven't tried that. So let's try. I want to get 1 near. I need to sell for 6 bananas. Let's see if it works. So it calls again Berry Club transfers the wallet, but to a different contract. And we currently don't display arguments, but eventually we will. Okay, so it's saying I transferred, and I suppose I got 1 near. So if I go back, right, so I got 1 near, I spent 6 bananas, which is cool.
Is there a profit being taken on the swapping side?
Yeah, so you cannot add to liquidity, and it takes 10% right now. So it's very generous contract. All right. So this is the UI, and let's go. Let me present the contract. So you'll start with banana farm contract, but you probably will need to take a look at actual actual token contract from Pixelboard and also like from Berry Club, as well as the one that sends tokens. Okay, that's not easy to use. Okay, so Berry Club has a hard-coded contract called farm contract ID. When we actually haven't reviewed this stuff. When you draw, it verifies that you don't draw empty pixels. Otherwise, you can just trigger a reward without spending avocado. Then it calls maybe send reward, which verifies the time. It gets the current time from the blockchain. It checks that the next reward timestamp is less than the current time. So the next reward is either a beginning of farming time, which was a global timestamp that originally enabled like a 26-hour countdown, and or last reward timestamp when we last time triggered it, plus 60 seconds. So if it's time to send the next reward, it remembers the current time, it calculates the reward based on this logic. So it takes the current balance of a Berry Club. It takes the current storage, computes storage by the storage cost, plus some safety margin, which is 50 near. So it always keeps 50 near for the future balances. Then it's saying if balance is available, like our balance is higher than the amount we need for storage plus safety, then we calculate liquid balance and we divide it by portion of reward that we'll give at the every time, which is 2460, which kind of, if you would call it every minute, then you will drain majority of account, but it always kind of decreasing on itself because the balance decreases on itself. So, but it mostly gives all balance within a day if you would call it every minute.
Could I ask a newbie question?
Mm-hmm.
So I think like there's a kind of a broad stroke a thought that I've heard in blockchain where like be very careful when you're using stuff like the timestamp from validators, because a validator may be incentivized to tweak that or something, say that it's like 6 seconds earlier or whatever. So this is a little bit tangential, but like I see you're using timestamp here, but that's just because, I mean, all the worst that can happen is someone can try to be a few seconds earlier, they're going to get paid out. Is that true?
Well, first of all, you cannot produce a block that is timestamp earlier, and then you cannot produce a block beyond your slot, which is you have a dedicated slot when you need to produce a chunk. So the most you can do is produce a chunk of the final, like at the final millisecond of your slot, which is like 1 second ahead. So you cannot really move it way forward, otherwise all the other nodes will break the protocol as well. So they are limited by like their understanding of the time plus some like bar that they use to whether accept a block or not. So you cannot really make a time run faster unless all validators want to do this, which means we have maybe not. So the validators, they will stop following the protocol essentially, and they need to coordinate their time.
Okay, cool. It sounds way more secure than I was imagining.
Plus, you're kind of limited by like a minute. So even if you can do multiple like maybe you can like speed up time like 2x, then you'll just get rewards twice more frequently, but it doesn't really change much. So at the end, it get the reward. It's saying, I'm going to distribute this reward. And what it does, it calls farm contract and calls stake my near. And it just doesn't pass any arguments and passes reward and gas, just minimum amount of gas needed to add the balances. So that's how Berry Club was updated to start distributing rewards after every drawing, potentially. It takes like slightly more. So it uses gas that was spent on drawing to actually distribute the reward occasionally, which needs about like 10 tera gas for this. All right, and so let's go to Berry Farm and start with this contract. So the way Berry Farm works, it needs to, in constant time, be able to distribute rewards based on total number of cucumbers, which is not a trivial task. It's somewhat similar to staking pool and how staking pool distributes rewards. So staking pool creates a bunch of shares for every deposit you make. And the share has a current global price that's saying, hey, I purchased or minted more shares, and now my shares can be redeemed towards a given number of near tokens. So the share price is starting from 1, so 1 yocto to 1 share, and then the more rewards you accumulate, the more like price of share go up. So when you unstake, you sell shares at the current price and you get near back and it's unstaked and it rounds down. The challenge there is when you stake cucumbers, the price of a cucumber is 0. So when you first stake them, you cannot really like buy shares and win shares because the price of them is 0. So the logic of shares do not work very well for this. So for this thing, I needed to create something different to do the accounting. So let's go into examples. So let's say Mike is the first person who deposited 10 cucumbers to the contract. And then, let's say 100 near was distributed. So Mike will take all the rewards because he's the only one. He controls 100% of the share on a berry farm. Now, Mike, for example, was offline and didn't claim them. So we cannot really update his account because it has to be done in constant time. We cannot iterate through all accounts. But we somehow need to remember that Mike got all near for his cucumbers. Now, let's say Josh comes in and stakes another 10 cucumbers. Now, Mike's share is 50% and Josh's share is 50%. But Josh staked cucumbers after this initial 100 near was distributed already, so he is not entitled to any of this. Now, another 100 near drops. Mike now needs to gets 50 more because of 50%, and Josh gets 50. Now, when Mike comes back online, we need to be able to display his balance at 150 near that he earned in a constant time. So this is the challenge that we needed to address with this contract. And the way it was solved is by having a ratio that is global called near per cucumber, which is saying how much near received by a given cucumber balance. When an account is created or touched in any way, we remember the last value of this fraction. And then we have a near balance. So if the last fraction was lower than the current fraction, it means we can multiply cucumbers of the given account by the difference between two fractions and calculate how much near I'm entitled to. So when Mike's account was created, the fraction was 0 divided, let's say, by 1. And when 100 near was deposited where the total cucumber count was 10, this fraction became equal to 10. Then once Josh joined and dropped another 10 cucumbers to total, and another 100 was distributed, this fraction was increased by 5 because there was total 20 cucumbers and 100 near. So 100 near divided by 20, it means 5 near per cucumber. So this became 15. Now, when Mike comes back, he looks at his cucumber balance, which is 10. Amount of near per cucumber on a global contract is 15. His last remembered value is 0. So he just takes the difference, which is 15 multiplied by 10, and claims this balance into near balance, and this one set back to 15. When Josh comes back, he gets this value was at 10, and he has 10 cucumbers, and the current value is 15. The difference is 5 multiplied by cucumber balance of 10 gets 15. So that's how we manage near balance. Or like appropriate the rewards received by from people using oops, I copied something. Using a constant time to recalculate it. So instead of keeping entire fraction in memory, so we use a global denominator, which is fixed, and I used it to 10 in 18. which is same as precision of cucumbers, bananas, and avocados. So let's so that's kind of background how it's all computed. Let's look at the main structure of the contract. The contract called farm. It has a lookup map of accounts, and it uses short hashes similar to a fungible token with vaults. It has the banana token account ID, which can be hard coded as well, but it was used from the contract because we can actually pass it because this account was deployed after, and I didn't want to upgrade banana or like Berry Club contract state, so I didn't want to modify the state again through upgradability. So instead, I hard coded the value in the previous contract. Now, near per cucumber, this is the fraction that I explained, and this is numerator. Total cucumber balance, total near received, total near claimed. This is actually not needed. This is also not needed just for statistics. This is needed as a denominator. Vaults and next vault for transfers, they actually probably was never used to transfer cucumbers, except maybe once for test. So this is what we saw before. This is again a hash of the account ID. And account structure is the last value before the account was touched of this fraction. Near balance. So this is the balance, unclaimed balance. So whenever you touch an account, either by depositing more cucumbers or claiming near, it updates last value and moves all the unclaimed near to your local balance out of the difference. And cucumber balance is your balance in cucumbers. And finally, near claimed is the statistics that just saying how much reward you already claimed. It's not needed for contract logic. There's two helper structures just for front end. So human account returns values in more readable way, and human stats is like statistics, global statistics for consumption. Okay, so we disabled default. There is a high-level API.
Can we back up a little bit to the, I just want to make sure that I have the correct mental model for the global fraction. Is that what you're calling it?
Yeah.
My like metaphor for this that I'm using is that it's kind of similar to the way like a flex box element is divvied up, but I don't quite get how it's changing per minute. So like my mental model is like Mike pays in 10, right? Like he's the only one who's there so far. So it's like having one element inside a flex container, it 100% goes to Mike. When Josh comes in and puts in 5, now there's 15 total. So Mike is going to get a 10 share and Josh is going to get a 5 share. And so that means Mike gets 2/3, Josh gets 1/3. That makes sense to me. How does it change with the like per minute? What's the like walk me through that again in terms of like Mike was the only one there in minute 1. So when the block reward, when the like reward is calculated at the end of that minute, it will look at who paid in within that minute. Is that?
So it uses the total balance, which is this one,
Which is going to be 10
as a denominator. Originally,
that's what Mike paid in.
Yes, 10, and it calculates how much near. If you would like deposit originally and never touch your account, then you have some fixed balance of cucumbers. So whenever you change this balance, you touch your account. So, and then
Sorry,
this,
I didn't follow that.
so let's go into this function to actually take a look how it works. It may be slightly more clear. So it's called take my near. That is a Berry club calls. It attaches a balance, attach deposit. So first thing we check that there's enough cucumbers there because we use it as a denominator. So before this, it is say I don't take near because no one takes enough cucumbers, which is one cucumber needed to actually trigger this. And this is just precaution before, so you don't like trigger this type of stuff or like explode this value. So what happens is you get amount of near and yocta near, and you multiply it by denominator global. So you solve in a fraction, which is something like near per cucumber divided by denominator plus new balance, or like attached balance, divided by total cucumber balance. By yeah, something like this. So this is actually numerator, not really near per cucumber because it contains a denominator. So near per cucumber is actually numerator is denominator plus touch deposit, which was previous denominator. And if you want to delete this, then you just divide it by denominator, right? So this is the formula we use to calculate the new near per cucumber. It's the old value, which is this, or we can have it split into numerator, denominator. Denominator doesn't need to change, so it's always like 1 or 10 and 18. And you calculate this new value. Does this make sense?
Kind of. I feel like I probably need a little diagram or a little like, I don't know, something. But I trust that it makes sense, but I'm having a little bit of a hard time following.
So sure, yeah, that's what I was using, like drawing it for a while before I figured it out. So Mike's value is was 0, and once it became 15, multiplied by denominator, but whatever, then we'll get to the claiming actually. So when you're trying to claim, you have account.touch, and account.touch does the following. It calculates the difference between global numerator and your numerator. So then it multiplies it by your cucumber balance and divides by denominator. So you get the balance you earned in near. We add this to near balance and reset to the current value. So pretty much it always, whenever you touch an account, it always makes your current unclaimed balance, or like unclaimed difference between two, to a fixed number. And then you can modify any of the values without breaking the logic.
So how does the front end eventually call this touch method?
It doesn't. It automatically that like called by every getter and every change method. So before you modify the account, it always calls touch on the account. So for example, get near balance. So we get the internal account. If account exists, then we touch it locally. Then we just get you the near balance. Or if you get the account, we touch it before, then get you near balance, cucumber balance, and claim balance.
It's wait a second.
Yeah.
Yep, those are view functions that are changing things.
Right, but it doesn't save it, so it just temporarily changes the account value.
I don't.
So it doesn't save it back.
It doesn't save it back. I don't get it.
It just like makes a touch, which is just kind of recompute with the latest value.
When does it actually save it?
So when it saves it when you actually do any change call. So for example, call to claim near. So we get your account, and this one get mute account actually touches the account. So you get the account that is already updated. So near balance is actual balance. So it takes near balance to 0. It's saying you claimed all of this. It saves your account. And then if you claim positive value, then we will transfer it to you out of your account and say, oh yeah, I actually like transferred globally this value. And it returns how much near you claimed. Or if you,
I don't want to get stuck on this, but I guess I just don't understand what the view methods that change something, changing it in memory, but then but then someone will have to do a change method that like spins up the VM, loads the contract, does all this stuff in the memory, like starts over from scratch, right? Or do I not understand how that works?
So that's the beauty of this touch method, because it can be called at any point. It doesn't have to be called at a given point. So it's always gonna give you the same result, no matter whether you called it twice in the middle or called it once.
So this is just returning what this is just for returning to the user like how much they've got.
So it doesn't. Right. So it just tells you how much near you earned, kind of by calculating from the current state.
Gotcha. Okay.
So let's look at how you actually.
It's a noteworthy trick. I feel like that's a pattern that I would not have come up with myself. That like, I don't know. Should we? I just want to call it out. I want to note it, and then we can move on.
So on Berry Club, we do the same stuff. We have touch as well. And this is needed because, let's say you want to know how many bananas you farmed. Because we know last time you touched your account, like when you last draw something, we know how many pixels you have. So we can calculate from a given time to the previous time, multiplied by the number of pixels you had, how many bananas you should have right now. And the front end just does the same thing. Like front end simulates it. It gets the same info, except latest. And then it just creates a timer going forward that calculates it. So in theory, this particular method doesn't have to return you near value that is up to date. It can just say, oh, here's a total cucumber or total near per cucumber, and your last total and last near per cucumber, and also your last near balance. Like, do calculate it yourself if you want to. So instead, it's done on the contract level. So let's say we didn't have view methods for which you don't pay and only retrieved a state, then you would have to do this logic on the front end instead of doing it here in memory. Okay, so the final logic that we need to do is actually how you receive your cucumbers from Berry Club. And this is done by using transfer with Vault from Berry Club. So we did this. We discussed this before, how the NEP 122 works. So you pass receiver ID, amount, and a payload. It has a check assert paid, which just checks that the deposit is positive. So it's saying, oh, you need at least one octanier to prevent function access key calls to avoid malicious Berry Club UI to drain all your bananas. So it gets the gas and then it initiates a call. So it puts bananas into a vault and it initiates call to receiver. In this case, we call it on farm contract, and it passes sender ID, amount of bananas, a vault ID, which is just a U64 without JSON, and a payload, which is a string. In the previous example, when we were talking about NEP 122, the payload was a VEC U64, a binary of VEC U8 in base 64, because it was burst serialized payload. But as during the discussion, I noted that if you would review this argument in a wallet, like what you're trying to do, you will not be able to see the payload that you want to do. So in this contract implementation, we actually use JSON for the payload. So we inserted JSON from string payload, and it's an enum with a single option called deposit and stake. So now when you do a function call from farm UI that will go to the wallet, in the arguments, the actual payload will be like a string within a string, a JSON string within a string saying deposit and stake, instead of being some zero encoded as a base U8. Like instead of being a burst serialized version, it's a human readable one. So it may help you to this contract that has different payload types, such as Uniswap, for example. It will have a payload saying how much near you want to at most receive, or like at least receive. And the malicious Uniswap UI can just actually replace this value. And if you didn't verify it on on a wallet side, then you may actually get robbed on the bad fee or front end. Anyway,
could I ask a really not weird question? On line 220, I'm just curious why you're using like references on for the. Is that just a little bit more efficient?
Because in order to compare local string, I think I need. So I actually don't know if this can work, because this one is a string, while this one is not a string. It's a reference to a string. Otherwise, I'll have to copy it out of the self. Does it make sense?
Oh, okay.
Because I get a mutable self. So,
you have to clone it.
Yeah.
Okay.
It can be assert, but I think asserts are slightly more expensive than doing this, because this is like doesn't create debug info on the two variables that mismatched.
Cool, thanks.
It doesn't create formatting and debug info. So
this is another thing to put in the like pro tips. I don't know.
So this is actually interesting. There's an effort about no STD going on, and I assume once we swap STD format to something like a core quick format, or whatever it's called, we may also need to swap asserts macro to stuff like this, and it will be like as cheap. But also, if you at least once used assert and format somewhere in this file, it doesn't matter, because cost of this will be like almost zero difference. Just another small format. All right. So we get the account using get mute account, which gets either an existing account, or it creates a new account where it set all balances to 0, but the last near per cucumber numerator to be the current one global, which means you didn't farm anything and you have 0 cucumber balance. So it does touch anyway, even if it doesn't need to. So we can have avoided it if we did map. And then it returns hash and the account. And it's already up-to-date account. So what we do, we first increase the total cucumber balance, and then we save it back to state of the account. And we also increase the global cucumber balance by amount of cucumbers you deposited. And then we don't really verify that the vault contained cucumbers. So we trust that the previous caller, which is a banana contract, actually put this bananas into the vault. And we return this promise out of this method. So it's a weird match with a single entry, because payload can be only one type right now.
Why write it as a match? Just because you're anticipating adding other kinds of payloads?
Yeah, just like to be like a kind of future proof. Otherwise, I can just ignore a payload and like say, oh yeah, you don't need to pass a payload, but this actually gets you some verification that it's correct. Cool. So yeah, we call withdraw from vault. We're saying the amount we want to withdraw, which is a full amount. And then we call it back to the banana token account ID, which is a Berry Club contract. And that's it. So even so, this contract didn't receive bananas yet, it doesn't care, because it doesn't use bananas anyway. So it doesn't need bananas before it can proceed. So no matter how long it's gonna take, like cucumbers are there and the vault is already locked, so this is fine. And that's it. That's how you get the banana or cucumbers, and also increase the total cucumber balance by diluting the shares of everyone. So now when claim near, when take my near arrives, it will use the new total cucumber balance, and now it will split across all participants, including you, with your number of shares. And there's that's it. So this is the logic of the farm, but you can see there's another module that we actually haven't even needed to touch. And this module is a fungible token on top of cucumbers. It has a trait that implements the vault NEP 122, and then it has the implementation, which is very precisely similar to bananas, except for using account IDs. And it has, it doesn't have a method to register an account. So you cannot, one second, where is it? In withdraw from sender, or maybe in deposit. Right. So it expects that deposit account already exists. This so to avoid spamming through transfers. So the only way to create an account with cucumbers is to deposit at least one banana. And there is no method to unregister an account, so we don't need to handle a case when the account is deleted during the vault transfer. So that's it. Basically, the banana farm is just this part is just copy from other contract, mostly just with small modifications, but it's a perfect example of how to implement tokens. So long as you have some like helper methods such as get internal account and get mute account, which touches the account. So maybe if we introduce this as a trait as well and create a dependency, something like plus like account getter account manager, and then do something like trait account manager, which is gonna have berry farm this interface. Okay, one second. So what we can do is basically, if you standardize these three methods, and then say that the farm is actually implementing account manager for farm. All right, I need to do a touch. So see if the compiles are not. So this Rust interface telling that this trait depends on this trait, even so it doesn't have to. Then I can just have a default implementation for a given trait, such as I can potentially do this, probably not. So yeah, nearby doesn't really support this. So if I created internals and then just have a wrapper, then potentially I can create a generic token trait that implements everything here, except for get total supply, which also needs understanding of the self. But that's a minor thing. But the goal here would be if we can standardize a small account manager type, then potentially and we need a trade for account, then potentially we can create a crate and publish this crate, which is a fungible token implementation for a generic account that will allow you to just say something like impl nep 122 for farm, and then you just need to do a bunch of wraps for near binding, and it will just use the internal logic that is common with vaults and identifiers to start working with your contract, and you will have an apt122 interface working for you. So this would be cool. And I think it's worth doing this effort as long as we can standardize certain things, such as account. Right now it has near balance, but we need to trade something like account, which is maybe has a, or account manager has a get balance for a given account. So then you just implement some wrappers around and given a variable to increase balance, decrease balance, or like deposit, withdraw, and then you're done. So that's it for
Nice.
this particular contract.
I will say this one, a lot of this went over my head, but I think that we can use this as a model for a lot of stuff. One thought that is slightly related to this that I think would be really fun, because it seems like you keep iterating this Berry Club, which is great. I know one like hot topic right now and just like crypto Twitter and crypto in general is like, what's the best like bonding curve if you're trying to, you know, incentivize people to start using, you know, Berry Club version 2 or whatever. Like people get like better returns in the beginning, and there's all these like curves that you can see that like benefit either early adopters, but also will benefit, you know, folks later on as well. Like, have you thought about adding token bonding curves or anything like that to this?
Well, it's also hard to track. So like, if you didn't thought about some kind of like historic data that you need to save, then maybe it's a problem to add this later, especially with bonding curves that usually require time. So I don't think for any of the accounts I have time on chain. So it's all like not on chain, but on contract level. It's all on the historic chain level only. So you pretty much need a live client of near to prove something at the historic event that like this a given account, let's say, was created at a given time and spent so much near. So if this data is not on the contract side, then it's hard to get it. Any other questions?
So what's next? What's next for Berry Club?
I don't know. So Berry Club has a bunch of people who tries to like overdraw on top of existing art. So in order to avoid it, I added a opacity feature. And opacity feature, let me just show it quickly. Doesn't actually change the mechanics of of a contract, so it doesn't require a contract change, but it's mostly only a front-end change. So this is a new bar that is set to like 20% by default. So if you want to try to ruin banana, so if you draw on top of banana, then it doesn't actually destroy it, it just makes it look very dirty. And you can see like it actually resembles some art instead of just being fully random as in the past. Also, solution for this may be to set a default color to something like either white or black, which will make all farmers like just instead of making a random noise, make it like darker and darker over time. So you like art is fading out, but it's not unified.
So if you set the opacity, I guess, to be whatever you call that, the solid color, does that cost more?
No,
Okay.
it just gives you a warning saying like don't destroy art. If you want to farm bananas, draw with low opacity. But yeah, so if you draw with just like put a fully opacity pixel. So let me farm bananas. 6 bananas for 1 year right now on banana swap. I don't know if
advertisement.
if you can get this deal from farming cucumbers anymore. Any other questions on what we discussed today? Like, no?
Cool, thanks.
Yeah, thank you.
So I think the next thing would be really cool if we can unify or like design some type of crate for NEP 122 where you don't really need to implement any of this logic and just like either have some type of derive or just implement it using traits.
Is it possible to do that? I guess if you did it just in WASM, it doesn't give you as nice of tooling. Like,
yeah, I'll experiment with near binding to see if binding expands values on implementation. So let's see if it still compiles. And okay, let's try again. Let me present the contract to see if we can get this to work. So what I'll do is, let's say we can create a trait. Path trait test, and then we're gonna implement a method. Let's say test1, like ret1, and then it should do self and return you 64 and will return 42. So what it does, it has a default implementation for ret1. So what I wonder if I write impl test for farm and then put near binding on it, will it actually expose my method or not? And then I need to near dev deploy dairy farm. If it does, then it's super cool because you can actually implement logic in a trait as default methods and then just import and all you need to is do non-default methods, so like methods that actually require, so something like get total supply or get balance. And then account manager can potentially like increase balance, decrease balance, or like change balance. So yeah, near view this red one. Right, so method not found. So it means near budget by default doesn't export this methods. At the same time, if I do, for example, red2, and say 43, or red1, then, well, not really. I need to actually do this here. And then I can do red self, red1. So basically, I will have to potentially proxy all the methods to internal methods, or we need to modify near bindgen to something like near bindgen trait if it's available. Probably not, because it only has access to the local thing. Maybe it can iterate on a trait methods and expose them all. Okay, I need to deploy it. Contract, sure, is not initialized. Well, but at least it has the vehicle. So this is the way you can do this. So we can basically have a something like nap 122 trait that contains something stuff like transfer raw, mute self, blah 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 blah, and then has all the logic, and then you just expose transfer raw, mute self with the same arguments. And internally, maybe you just copy this piece and just do proxy to the arguments. And it will be a little ugly at the beginning, but at least you can reuse this. So it worth trying to do this.
It'd be a big step. It'd be awesome.
Oopsie. Cool. Well, thanks everyone for listening and asking questions. See you next time.
Cool.